We finally welcome Nicol Jacques from the City University of New York, USA, who is going to show us how anthropogenic noise disrupt habituation to conspecific song in Jacques Finches. And I will play the pre-recorded video. After that, Nicol will answer the question.
All right, so hi, my name is Nicole and I'm a student at the CUNY Graduate Center. I'm a PhD student specifically in the Comparative and Cognitive Psychology program. Today I'm presenting a project called Anthropogenic Noise Disrupts Habituation to Conspecific Song in Zebra Finches, which is a big fancy way of saying I'm here to talk about how traffic noise influences auditory perception in songbirds. So I currently live in New York and it's a very densely populated place, so I wanted to share some anecdotal stories about how noise affects my language processing, which some of you guys can relate to. So yesterday I was trying to read something on the library and people kept whispering around me, which meant I just couldn't pay attention to what I was reading. So even though I could physically see the words and hear them in my head, I wasn't able to process them as well as I could normally because of this background noise. Like, why would you whisper in the library? Also yesterday, I was taking the subway home with my friend, and when the trains go by, we can still technically hear each other, but the sound tends to just be so distracting during this that we tend to just stop talking during it. The background noise just becomes so cumbersome, it kind of makes us forget what we're gonna say and thus hinders our communication. In both of these examples, although I'm fully capable of physically attending to the reading that I'm doing and the conversation that I'm part of, anthropogenic or human-caused noise just worsens my ability to do so. And I study birds, so I began to wonder if human-caused noise is highly distracting to me, is this human-caused noise highly distracting to animals, and more specifically songbirds as well, who rely heavily on these acoustic signals for things like territory defense, mate attraction, etc. And I'm not the first to study how noise affects communication birds. There's already been some really interesting findings. So in zebra finches, which is the bird I currently work with and this focus of this presentation today, young males copy the song from their fathers or other males in their surroundings, and their song similarity or stereotypy to this tutor increases with time until they reach this nice crystallized song. Essentially, their vocalizations become like their tutors, and this is a learned ability that is argued to be similar to how humans learn language. This process takes around 90 days. However, research has found that if you play traffic noise while they're learning, they take 30 days longer to reach song stereotypy, which is shown in this orange line. So typically they take around 90 days, but in traffic noise, they take an extra 30-day month period. Within this learning as well, the traffic exposed birds tend to make more errors while they are learning. So overall, this suggests that traffic noise impairs song learning and production in juvenile male songbirds, making them take longer and sort of be worse at this learning process. There's also neurological correlates to this. So in zebra finches, there's this brain region called area X that is linked to song learning in young male zebra finches. And in moderate and high levels of traffic noise, which is shown here, area X volume actually decreases. Additionally, there's another song production region in the brain called HVC, which aids with song production in both juvenile and adults, and this volume of this region decreases as well if the bird is exposed to moderate noise. So overall, traffic noise has effects on the developing brain, which could also lead into having lasting effects for these birds when they're an adult. So overall, we know that traffic noise impairs song in these young male birds, but I'm kind of wondering about adult birds as well. And also, these studies are focusing on how traffic noise impairs the song learning as they're juveniles and song production, whereas I'm wondering if traffic noise also impairs song perception. So I'm kind of wondering, are the birds like me, where they find it harder to attend to sound-based content when there's background noise? So my research question becomes, does background noise impair learning for conspecific vocalizations in songbirds, these little guys here? So to measure this, I was kind of limited on tasks that I could do with my birds because they were being used for other experiments, but there's this pretty non-invasive behavioral test that I found called the habituation dishabituation test. So habituation is a form of non-associative learning which measures a decreased response following repeated stimuli presentation. So my favorite example of this is like imagine if someone starts tapping your shoulder over and over again while you're trying to work. And at first, this is kind of annoying, like why are you tapping my shoulder? But if you think about it over time, you can sort of tune it out and continue focusing on what you were doing before that happened. In birds, the repeated stimulus is a song or a vocalization that the bird habituates to. So for my procedure, the zebra finches go into this box and it has a camera that I'm recording them and a speaker, and the zebra finches are going to hear a repeated novel conspecific song. So it's from their species, but they've never heard it before, and they hear this repeated over and over again for 36 minutes. During the first 10 minutes, the zebra finches typically decrease their activity and they're sort of still, they're looking around, and not to anthropomorphize them too much, but I think that they might be thinking, like, what's going on? They're a little confused. Who's there? Is this bird maybe a threat to me? Where is this bird coming from? What's going on? After 10 minutes passes, though, the zebrafinch sort of stops this thinking, and they sort of resume their typical activity, including vocalizations, hopping, flying, and grooming behaviors. Once they begin these behaviors again, this marks a behavioral habituation to the stimuli. So I was wondering what would happen if I played realistic levels of traffic noise during this, and how would their behavior change? So I record at least 10 minutes before the experiment starts to get a sense of what the bird is doing, and I'm recording all of these movements that they're doing. So what's shown on the y-axis is a composite of all of these movements, so adding together their eating, their drinking, their hopping, flying, grooming, etc. And for birds who are going to receive the repeated song in silence, which is shown in this blue dotted line, they are making around 18.8 movements per minute. And for birds who are going to receive the repeated song in noise, they are making around 16.2 movements per minute. So the groups are sort of behaving around the same before the experiment starts. And when the song begins in silent conditions, my birds do what is kind of expected of them. So while they're making around 18 movements per minute before, they're now making around 5 movements per minute on average. Some birds will stay almost completely still during this time, but some birds will sort of begin moving around like a little bit earlier. But in almost all birds, it's like a gradual increase as they habituate to the stimulus. Also, I just wanted to say that the trial is going to be 36 minutes long, but I'm just showing the first 10 minutes because that's when the bulk of the behavioral habituation is occurring. However, when the song begins in noisy conditions, birds are still momentarily shown by this sort of like decrease initially in the first minute, but then around like 30 or so seconds, they typically go back to their normal activity. So now they go back to making around 18 movements per minute, and before they were making about 16 movements per minute, so there's not really a big difference. So it seems that birds are not reducing their activity when they hear song and traffic noise as they typically would do in silence. And this graph is sort of showing a similar thing, but it's showing the behavioral latency, which is just the amount of time that it actually takes these birds to make their first movement. On the bottom, this text is a little small, so I'm sorry, but it shows the male birds, the female birds, and then the average of these birds. The main takeaway here is that if song is presented in silence, then it takes longer for them to make their first movement. They are sort of freezing. It does look like maybe females freeze for a little bit longer than males, but there isn't a effective sex. If you look at their total activity again, if song is in silence, their activity significantly decreases compared to their baseline. So that's a paired test. And it also significantly decreases compared to song in noise. Once again, there is no impact on or interaction of sex on activity, despite females being a little bit less active than males. However, I did get kind of curious because like while I was watching these male birds and noise here, it did kind of seem like during the first 10 minutes of noise and song exposure, um, they were getting really active. And in the ANOVA, there was this sort of trending interaction between environment, sex, and condition. So I was wondering what would happen if we just looked at the effect of song and noise between males and versus females. So just comparing these two groups right here, what would change? So I found that although males do have increased activity, they make around 23 movements per minute in noise plus song compared to females who make around 13 movements. This difference was not significant. Uh, And I think that even though it wasn't significant, I do think that change is slightly interesting because during the baseline, there is no difference to how males and females would typically act. So during baseline, males and females are both making around 16 movements per minute. So it seems to me, although this isn't significant, this increase may be related to the traffic noise. And I can't make any definitive claims, but since song is a form of sexual communication, I was wondering if hearing it in noise had different effects for both males and females. Also, based on this, I was wondering if the increase in males was coming from traffic noise or if it was specific to the song and traffic noise. So I ran a few male birds in noise only, and I found that traffic noise itself did not seem to increase activity. So just playing traffic noise, the birds didn't really seem to care. So overall, the current takeaway is that traffic noise disrupts normal behavioral responses to conspecific song. Zebra finches do pause a bit when they're hearing the vocalization and noise, but it's not that long, and they instead just continue normal movement. One possible explanation for this is that habituation is typically shorter to less salient stimuli. So if a stimuli stands out less in its environment, it's essentially easier to ignore. In this case, song stands out less in the environment with traffic noise in it, so habituation is much faster. Another possible explanation is that zebra finches may not even be able to detect the song stimuli. So I play the songs at 80 decibels, which is pretty loud, and the traffic noise is 65 to 75. And I chose these values because this is the average traffic noise volume in New York City, and 80 decibels is the volume that they will sing in this noise condition. So they typically like increase their vocalizations and noise. But I found this study in 2003 that was suggesting that zebra finches require a ratio of the sound being 26 decibels louder than the background noise for these birds to even detect the sound. I don't really know how much I buy that finding because in separate experiments we do, we usually only play the sounds about 20 decibels louder than the background noise to be heard. But I think it's interesting if that's true because even though animals typically are vocalizing louder in noise, maybe these adaptations still don't fully counter the effects that we humans have on their environment. So right now, this project has low-key been on hiatus due to other lab projects, but once I can start again, I'm gonna finish this like repeated measures design that I've been working on. So I have birds who are receiving silence and song first, get traffic and song second with a different song about like a month later. So there's a long washout period. And interestingly, so far, even though they're being tested with like a completely new song, birds, if they are hearing the silence and song condition, don't become still and seem to not really care and they don't habituate. So to me, this suggests that if they receive traffic noise and song first, maybe they're like remembering something about this song, but I'm not exactly sure what's going on here. I just know that the design is not working. Second, I want to see if an overnight noise acclimation leads to differential habituation because currently the baseline period is just silence. So I'm kind of curious if maybe if birds have more time to habituate to the noise itself, maybe once they get exposed to the repeated song stimulus, maybe they will have similar rates of habituation to the birds that are in silence. Anyways, thank you to Animal Behavior Live for letting me speak today about this project. Thanks to my PI slash mentor, Dr. Carolyn Pitta, and my three undergraduate research assistants, Sean, Amala, and Melanie, for helping me with ethograms, which I'm sure many of you all know can be quite the labor of love. Yeah, so thank you so much. I'm open for questions now, and I put a QR code to my references here that you can scan if you're interested in any of the studies that I talked about. So thanks. Hi.
Yeah, such a great presentation, Nicole. We already have a few questions from the audience. Um, One question from David. If traffic noise does interfere with learning, what is the effect on the development of the bird? Will it interfere with mating?
Yeah, it's a good question. So the traffic noise impacts the male zebra finches learning by making them take longer. And actually for the young male zebra finches, once they're done with this learning, they can actually just go out and start mating. That kind of marks the end of their puberty, the end of their development, and they can get out there.
Mm,
If you think about it, if you're a late bloomer because of the traffic noise and it takes you longer to be able to like sing, then you might lose out on mating opportunities and you're behind. And experience with mating and raising clutches does increase your fitness. And then for females, it seems like traffic noise makes them unable to attend to the male song normally. So I think that females will also be affected and maybe not make as informed of a decision
mm,
about mating as they typically would if they were experiencing these songs in
mhm.
traffic noise.
Right. I think you also just answer the question from Buster, how the traffic noise have an effect on female birds too, right? Um, and he's had another question, does it impact the ability to raise uh, chicks or the chick developments?
Yeah, that's a good question. I'm not really sure how it would affect raising chicks. I'm imagining if it affects it obviously is like affecting the chicks as they're growing up. As far as like the how the parents are going to be affected by it, I think it worsens their overall sort of like attendance to signals. Maybe they might not be able to hear like feeding calls from their chicks as well. That's not something I looked at. But it sort of raises a lot of questions about, if these sorts of signals are interfered with noise, then what else is going to be interfered with?
Mm, mm. So I have a question. Does noise exposure impair or delay habituation in to familiar songs?
Oh, well, in my presentation, I just talked about it. Well, it
Mm,
actually doesn't it impairs the habituation, but it doesn't take them longer to habituate. Instead, they
mm,
actually just don't habituate at all. They just normally they'll pause in song and then start moving, and then that's their habituation in silence. And
mm,
noise, they just immediately start moving again. It seems like they don't really care
mm,
at all about the song stimulus that they're hearing.
mm. We have another question from the chat. Have your birds been raised in cavities and never exposed to traffic noise? And do you have any idea how traffic noise differs from the regular background noise they are exposed to?
Yeah, that's a good question. They never have heard traffic noise before, because they're
Mm,
lab songbirds. They kind of just hear this. They're in a very social aviary, so they just hear like a constant cacophony of all the birds singing around them, which is pretty loud. It is actually kind of around the same rate of volume
mm,
that I play the traffic noise at. But I think that maybe they aren't used to it as well, which impacts their behavior.
mm. Yeah, maybe my last question. Are habituation and dishabituation responses less distinct under different noisy conditions?
What do you mean? What are you thinking by distinct?
If you can differentiate the habituation uh, change or dishabituation change when exposed them to different noisy conditions.
I've only done it to the one noise condition. I'm only using like the realistic levels of traffic noise. I don't want to do it louder because I think that would affect
Mm,
their sort of it's already pretty loud. I don't want to like make them deaf or anything. But yeah, that's a good question. I am kind of wondering if maybe I played it a little bit lower, if their habituation would also kind of change
mm.
with that graded background stimulus.
Okay, thank you. Thank you very much.
Thank you.